I just thought something in my head, and I thought it was funny. Anyways, what do I do first, guys, to solve problem number 10? I'm going to distribute the 3 through the parentheses, so 3 times x is what? 3x. Very good. See what happens when we pay attention? What is 3 times positive 6? Positive 18. What about, let me change the color so you guys can see what we're doing. What about, and remember, when I multiply, I'm multiplying by negative 2, okay? So what's negative 2 times x? And I'm going to point to you. Ready, go. What is it? You got to look up when I'm pointing to you. I'm trying not to say people's names because I'm recording. What's negative 2 times x? Negative 2x. Very good. Took a second there. You're so focused on learning. I appreciate that. Negative 2 times positive 2 is?
4. Negative 4.
Yes. All right, good. It's funny. You guys almost have to process it. And then we just tack on, right? What do we do next? Yeah, what's the fancy word we call that, though? Yeah, we're going to combine like terms. So those two, 3x minus 2x is just x, right? And then we'll do orange. I have never done orange before. This and this are like terms. So remember that 3x is a variable term. Variable term is just a fancy word for it has a letter. Variables are called letters. And then the number in front of the letters is what we add or subtract. So 3 minus 2. By the way, what's the fancy word for the number in front of the letters? Anybody know? Coefficients. So 3 minus 2x gives me x. I like to tell kids, okay, I have 3 x's in my hand. I take 2 x's away. What do I have? 1x. But now for the numbers, those are called constants. We just do the math. What's 18 minus 4? 14. Positive 14, right? And then everything else just kind of stays the same, is greater than 10. I probably should pull this up because I have a tendency to make mistakes. And then I'm going to post this on the internet, and then I'm going to get an email from somebody. You added when you were supposed to subtract. You're a moron. It's usually like a 7-year-old. That's all they do all day is just like troll teachers' websites. All right, so what do I do? You're next. What do we do next? I'll give you a clue. We need to move the 14. What's the 14 doing to the x? Mathematically speaking. Don't tell them. Oh, you got to take your... Oh, I see why you don't know what you're doing. Go ahead and take them all the way out. He's got his earbuds/earpods in, so he has no clue what we're talking about. Take them out and pay attention. What is the x? I asked him a question. He was like, he looked this way. He thought I couldn't. By the way, look at my face. If I do this. Huh? All right, so what is the 14 doing to the x? Mathematically, what are we doing? Oh, it's just huh? Well, that's what we're supposed to do. Thank you guys for shouting out the answer. But the reason we're subtracting is because we're adding 14 to x. To move the 14, we do the inverse of adding, which is subtract. So yes, we subtract 14 from both sides. 14 minus 14 is 0. 0 plus x is x. Over here, 10 minus 14. Now, I know that's negative 4. Let's say you're not good at that. Could I do this maybe? No. Minus 14. Hey, it's negative 4. Uh-oh, I got to move my face. So it is actually negative 4. Wha-bam with the bacon sizzle. That's the answer. I'm going to slide this over a little bit. Does everybody have that written down? Yeah. All right. Let's do the next one, shall we? Where did I leave off? Oh wait, my face over there won't work. I'm gonna put my face right there. What do I do next? I think it's your turn. We're gonna do problem number 11. Distribute. That means I'm gonna multiply this times this. Back to you. What's 5 times 3? Next person on the list. What's 5 times negative x? Yeah, there you go. See? You guys are smart. All right. Now remember, we're multiplying this by this. So what is negative 4 times 2? You're next. Negative 8. Okay, you're next. We're going to multiply negative 4. Whoops, maybe if I can draw the thing. Hey, will you shut that door for me real quick? What's negative 4 times negative 3x? Positive 12x, right? Good thing, right? A negative times a negative is a positive. 3 times 4 is 12, and then we just keep the x. And then, what about this other stuff? What do we do?
Combine like terms.
Well, not yet. We're not done. We bring this down, but you said the next step. Next step is combine like terms. These are like terms. What's 12 minus 5? 7x. Now, and let me tell you, I say it, but I don't know if you guys always look at the screen. I'm looking at the screen. I don't know if you look at the same spot. I'm taking 12 and subtracting 5 from it, and that leaves me with 7x. Now, for the next thing that we must do, wait, where's the color that I'm not using? I need to take 5, which is a constant, and negative 8 and combine them, which is also constant. Or you could think of it as 15 minus 8, which is 15 minus 8, what do you think it is? Positive 7. Now, I'm saying positive and negative, but really I want to remind you guys we're going to add. Adding a negative number is the same as subtracting. But for some reason, whenever I go and explain that in full detail, the kids get a little confused and then they start subtracting negative numbers. If I just say it's positive and it's negative, you write the right thing down. I hope and pray that if you go to college and try to get a degree in math, by the time you take some of your harder math classes, you figure that out. Right now, we're just trying to get by in algebra. So anyways, what do we do next? Well, we got to get x by itself. There are 2 7s that I need to move. So I'm going to give you some hints. All right? Very good. Very good. I didn't have to give them a hint at all. I had a student ask me this morning. She said, Mr. Adams, I don't know how to do this. I said, okay, well, what do we do first? She said, oh, we're going to subtract 3. I said, okay, subtract 3 from both sides. She does it. I said, what do you do now? She goes, divide by 4 on both sides. I said, yeah, okay. And had like x equals 4 was the answer. And I said, I thought you didn't know how to do it. You just got to try, okay? By the way, what happens if you try and you get it wrong? You're doomed to failure. No, you just try again. Absolutely. So now this one, 2 minus 7 is negative 5. Ooh, what is it that I don't like about this one? Yep, no, that's the right answer. So, I just wanted to make sure. So 7 divided by 7 is 1. 1 times x is, I'm going to write the answer over here, x. And then you just leave it as negative 5 over 7. That's the answer for that one. You can have fractions as answers. I mean, it's a math class. Most of the time, they rig them to where it turns out to be an integer, negative 3, positive 20, whatever. But sometimes, what is it that we don't like about this one? Fractions. Is there a way I could get rid of the fractions? Yes. Now, this one is going to take a little bit of work. So I will do this one up until we get rid of the fractions. 3 is the denominator in this one. So I'm going to say 3 times this stuff. You only multiply that by the this is what we call a scalar multiplier. So I'm going to multiply just this 1/2 by 3, just this negative 2/3 by 3, and just 4. Everything else kind of stays the same. So you're going to end up with 3/2, 4x minus 2. And then over here, this ends up becoming negative 6 divided by 3 is actually negative 2. Essentially, the 3's canceled. This 3 undoes the multiplication of 3, and you're left with 2. Times the quantity 6x plus 9 is less than or equal to 3 times 4, which is 12. I still have a fraction. So now I'm going to multiply by the denominator of that fraction. Oops. I'm all the way on the edge over here on this 12. So I'm going to multiply this by 2. And we've got some funny business over here. This is like a different problem. So let's separate that. So what's 2 times 3? 6. What's 6 divided by 2? 3. So that just stays 3. Okay? And that's times 4x minus 2. The stuff in the parentheses stay the same. 2 times negative 2 is what? Negative 4. The stuff in the parentheses stays the same. And then I got to multiply 2 times 12, which is 24. Can you guys see that okay? All right. So now I'm going to distribute through the parentheses. Now that I've gotten rid of all the fractions, 12x, 3 times negative 2 is negative 6. Then negative 4 times 6x is negative 24x. And then negative 4 times 9 is negative 36. And then this just stays less than or equal to 24. We're going to combine like terms. So I'm going to take 12x and add it to negative 24x. That's just negative 12x. Then we're going to take negative 6 and negative 36. When we combine those, that's negative 42. And then all of that is less than or equal to 24. I'm going to add 42 to both sides. Add 42. This is 66. These cancel, and I'm left with negative 12x. Divide by negative 12. Divide by negative 12. I'm going to write over here. I'm going to keep writing down. I get or not negative, the negative 12s cancel is less than 66 over negative 12. Both of these are divisible by 6. So if I divide this by 6 and divide this by 6, what's 66 divided by 6? 11. What's 12 divided by 6? 2. And I just put a minus sign here because the overall thing is negative. So I get x is, oh, it's not equal to. X is, well, that is equal to. So this reduces down to this. So that is technically equal to. So x is less than or equal to negative. Wait a minute. I made a mistake. You guys didn't catch my mistake. Do you know what my mistake was?
Yeah.
What was it?
I don't know.
When you multiply or divide across the equation, or inequality in this case, with a negative number, you always flip the symbol, guys. How'd you let me get away with that? So then that means this should be greater than. Whew. Trying to do a lot of stuff here. And this twerp keeps making these weird noises. Any questions on that?